everyone, today I'd like to talk about mass percent composition. So what mass percent composition is it's what percent of a total mass for a sample is due to a particular element. So percents are always part over whole. In this case, what part is an element that we're interested in, divided by the whole, which is the mass of that compound. Mathematically, we're going to find this by taking the mass of an element in a compound and dividing that by the total sample mass. And then to make it look like a percent rather than just a fraction, we're going to multiply by 100. So for example, if I have table salt, which is sodium chloride, in 12.7 grams of sodium chloride, I've got 5 grams of sodium and I've got 7.70 grams of chlorine. So the question is, what's the mass percent of each element? What I'll do is I'll take my part, so if I'm looking for sodium here to start with, 5 grams is the mass of just the sodium. And then the whole is the total mass of the compound, and that was 12.7 grams. I'll take that, I'll multiply by 100, and I get 39.4%. I can do the same thing for the chlorine. I'll take my 7.70 grams of chlorine. I'll divide that by the 12.7 grams, that is the entire mass, multiply by 100, and I get 60.6% of chlorine. Now I want to point something out. This is a percent. Percents always add up to 100. So because there's only 2 elements here, once I had known the mass percent for the sodium, I could have found the mass percent of chlorine by subtracting from 100. It's another option. Let's take a look at a second example. So in this case, I have 16.4 grams of limestone, so the rock. Limestone is made of calcium, carbon, and oxygen, and in this particular rock, actually in all limestone, you've got, in 16.4 grams of that limestone, you've got 6.57 grams of calcium, 1.97 grams of carbon, and everything else is oxygen. And our question here is to calculate the mass percent of the oxygen. Well, in order to calculate mass percent, I need to know the grams of oxygen. This we're going to figure out by difference. We know that the total mass was 16.4 grams, but 6.57 grams of that was due to the calcium, and 1.97 grams of that was due to the carbon. So whatever's left over must have been the oxygen. And this is 7.86 grams for your oxygen. Once you know the mass of that element, now you can take your part that you're interested in, which in this case is the oxygen, divide it by the total mass of the sample, multiply by 100, and you get 47.9%. And so, again, mass percent is always part over whole. And I want to point something out. For a particular compound, the mass percent of each element will always be the same. So if I have sugar, the mass percent of oxygen in a teaspoon of sugar and a pound of sugar and a giant bag of sugar you'd buy for a bakery, the mass percent is always the same because percent's really a ratio. And that ratio stays the same because it depends on what the chemical compound is. If you change compounds, you've got a pretty good chance you're going to have a different percent composition. But as long as you have the same chemical compound, the mass percents will be the same, regardless of the sample size, regardless of where you get that sample. It's going to be the same because it reflects what that chemical is. And the mass percents tell you that, which means if you have different mass percents for something, for the same element, you know it's not the same compound. Because if it was the same compound, the mass percents would be the same. They are consistent depending on the chemical formula.